Dear friends, once again welcome. Let us talk about the dynamics of robot or the manipulator. Dynamics of a robot or manipulator. So firstly, what is dynamics? So that is dynamics means study of the motion of the robot with the causing either forces or the torques. Okay, means what is means suppose a robot is there. This is a robot. So suppose it is theta 1 and this angle is theta 2, and for each joint there is a need of torque, like this one tau 1 and this one tau 2, and motion here what we get. So at the end effector the motion of the manipulator we get. So in the dynamics, in our study with we consider both, means what is the responsible for the motion. Okay, means input and output we are both we consider. Suppose in terms of input, so what is our input? So input is either force or torque. What about output? So our outputs are either the, like in terms of angular velocity, theta, theta dot, or theta double dot, means the angular position, angular velocity, angular acceleration, or you can say like uh, x or y. X dot means x, then x dot, x double dot, or y, y dot, y double dot. Okay, it is in case of linear x direction. It is in the case of linear y direction. It is in case of angular motion. Okay, so in which dynamics, in our study we consider both the motions and the forces or torques. Okay, so what about uh, so in dynamics, किसकी वजह से मोशन हो रहा है, that also we consider. But in case of kinematics, which deals about study of motions without considering the cause or its cause or causes the motion. Causes of forces or torques. Means here we consider only effects. And what are those effects? So same position, velocity, accelerations, and causes are not considered here, but effects are considered. So this is the basic difference between dynamics and the kinematics. This is the fundamental difference. Okay. So, but our focus is here, dynamics of a robot manipulator. Okay. So let us start our study for 1 degree of freedom. 1 degree of freedom. Okay, so this is our robot link, and it is our end effector, and the link length is suppose L1, inclined, it is inclined with the horizontal axis by theta degree, and the tau is being supplied, or tau is being generated. And tau कहाँ से generate होगा? From where? So from the motors or mechanical devices, or pneumatic, hydraulic devices. Okay, and this is what? So this is the, you can say, the robot hand, but the technical term is hand effector of the robot. Okay, so our purpose is to get about now x and y coordinates. It's a 1 degree of freedom planar robot. Okay, so now what we have to do? So as we know, what are the methods? What are the methods to analyze the dynamics of the robot? Okay, and what is a robot? So in a single line, it is an automatic reprogrammable and multifunctional machine. This automatic you can put here before machine. Okay, so this is the basic definition of the robot. The two keywords are there: the reprogrammable and multifunctional. That's why a CNC machine is not a robot. Washing machine is not a robot, because the due to limitations of reprogrammability and multifunctionality. So it is a definition of a robot. Okay, but our focus is here to analyze the dynamics of the robot. So what are those approaches or methods? So two main methods are there. Two main methods. First, the Newton-Euler method, and secondly, the Lagrange-Euler method. Okay, and it is based on the force balance equation, and it is energy balance. It means Lagrange, the second method, Lagrange-Euler method, based on energy balance criteria, you can say criteria. Okay, and like in Newton's Euler method, like F is equal to ma, or in case of the angular motion, it is tau is equal to I and alpha. Okay, so in Lagrange-Euler method, so let us discuss this one. Our focus is the Lagrange-Euler method. Okay, why? Because from this the complex system can be solved. A robot having, suppose, not only serial manipulator, the parallel manipulators are there, and the number of degrees of freedom are there. Okay? So in that case, better option is the Lagrange-Euler method. Okay, let us discuss what is this Lagrange-Euler method. So means Lagrangian approach, and it is Fi is equal to d by dt and del L divided by del x here dot, then put in bracket, then the second step minus and partial differentiation of L with respect to x. Okay, it is for x axis. Okay, for x coordinate. Similarly, one can write for the y coordinate. And what is I here? So I here is what? The number of joints. And this is for linear force. Linear force. What about for angular force? So for angular force means linear force and angular force, better to say it angular motion. Okay, the what about for angular motion? So tau is responsible for that, and tau I is here, and same d by dt. What is here? X is replaced by theta, means the linear variable is replaced by the means angular variable. So it is theta dot then minus del L divided by del theta. And why here partial derivation is here? So why partial differentiation we are taking here? So because the differentiation is with respect to the coordinates, which is known as generalized coordinates, not with respect to the time, not with respect to the time. Okay, so in this way we have done this, means the formulation we have written, and the main thing, what is L here? So L is known as the operator means the Lagrange operator. You can write Lagrange operator. Okay, and it is equal to K minus P. And K is what then here? K is what? So K is kinetic energy. And P is what? So it is potential energy. Okay, so what is the step? Firstly, when you are going to solve, then let us have the example like this. We have drawn theta here, L1 here, this we have, and it is tau, and it is for 1 degree of freedom. Okay, so suppose I number of joints we are taking here, I number of, या तो आप ऐसा कर सकते हैं 1, put superscript 1, and here the mass is concentrated. The mass is concentrated at the end. M is what? Mass. Okay. Okay. So, and it is 1 degree of freedom robot, and let us derive the governing equation. What is our task? Let's derive the governing equation for this robot. What does it mean? Means what? This is a theta is there, so obviously we have to take the tau. Okay, and suppose the 1 we are taking here for the joint 1. So what is the function of this? What we get? Tau 1 in terms of expression. Okay, so that is our objective. So with the help of now applying Lagrangian approach. So it is tau I is equal to d by dt of what? Of partial derivation with respect to the angular velocity, and minus partial derivation of Lagrangian means operator with respect to the angular position. Okay, so firstly what we have to know, means what is L. Our first step should be what is L. So L is K minus E, and what is K? So K is, already we have discussed, it is kinetic energy. So it is 1 by 2 m v square, we know. And what is E? So E is equal to m g h here. Okay, so now what is V? So how to get that? Our purpose is what is V. V is what? Okay, so let us find the x coordinate and the y coordinate for the given robot. So obviously it is 1 degree of freedom, so that's why L1 cos theta 1 and y is equal to L1 sin theta 1. And let us have, and this is 1, let us have the velocity of this. So x dot means what? Dx by dt. So what we get? We get here minus L1, because we are going to differentiate cos theta 1 with respect to time. Okay, so that's why sin theta 1, and the differentiation is with respect to time. So that's why अब क्या करना पड़ेगा? d by dt. Now here theta, so it becomes minus L1 sin theta 1 and multiplied by theta 1, and here dot means angular velocity. So similarly we can get y dot here, and it is L1 and cos theta 1 multiplied by theta 1 dot. Okay, so this we have. Now what is V? So V is our x square, means x dot square, y dot square, and it is under root. V is equal to under root of x dot square plus y dot square. So here what is x dot square? So L minus L1 sin theta 1 multiplied by theta 1, and it's dotted here, so it is square plus, now the y dot, this one we have to take, and L1 is, let us L1, then cos theta 1 here dot, and it's a square. So what we get here, L1 हमने बाहर निकाल दिए, and theta 1 dot ये भी बाहर निकाल दिए, तो क्या बच गया? यह sin square theta plus cos square theta, and it is equal to what? Means this is equal to 1. So that's why L1 theta 1 here dot. Okay, so now we know. So once again writing here, what is our kinetic energy? So kinetic energy 1 by 2 mv square means 1 by 2 m, and L1 and theta 1 dot square, so it is 1 by 2 m and L1 square theta 1 dot, and it's a square. Okay, and what about in the potential energy K? sorry, K, it is here P. K here P means potential energy. Okay, so P means potential energy, M G H, and H is what? H is what? So it is y coordinate, and the y coordinate is what? L1 sine theta 1. So this can be written M G and L1 sine theta 1 is equal to mg. So now we have both the potential energy and the kinetic energy. So what is the next step? The next step is ultimately we have to satisfy this equation. Okay, and what are the terms there? So here better if we start from here, then secondly first this one, then this secondly, and then differentiation it is thirdly, and then put all the values expression in this tau I equation. And the tau I is what? It is summation of all torques applied on the manipulator. So now the next step is partial differentiation with respect to, or partial differentiation of what? L with respect to the theta. And L is what here? So L is, better to write here, L is equal to 1 by 2 m and L1 theta 1 and square of both minus this P, this one. So m g L1 sine theta 1. Okay, so now we are going to differentiate this. So what we get? So partial differentiation of this 1 by 2 m L1 square theta dot square minus mg L1 sine theta 1 divided by del theta, and that is equal to what? So differentiation with this will be 0 because there is theta dot, it will be 0, and then we have to differentiate this. So what we get? We get differentiation of this with respect to theta. So here theta I, so obviously it will be theta, means theta 1, so theta 1 here, theta 1. Okay, so it is minus mg L1 then cos theta 1, and partial differentiation with respect to now theta 1 dot. Okay, so in this equation, writing again, this is with respect to theta 1 dot, and this is what? So here in bracket 1 by 2 m L1 square, then theta 1 dot square, then minus mg L1 sine theta 1. Okay, so because a differentiation with respect to the velocity, okay, but this is the position and the velocity is here. So here this will be what? This second term, the differentiation with respect to the velocity will be 0, then our focus is here. So it becomes what? 1 by 2 m L1 square, then 2 and theta 1 dot, and it is equal to what? It is equal to then this gone, then m L1 square, then theta 1 dot. Okay, what is the next step? So that is d by dt and del L divided by del theta 1 dot. So here we are differentiating this with respect to now time. Okay, so d by dt, and this is m L1 square theta 1 and that dot here. So what we get here, so m1 sorry m L1 square and this theta 1 डबल डॉट. ठीक है, क्योंकि एक डिफ्रेंसिएशन तो है ही, वेलोसिटी तो है ही, एंड टाइम के रिस्पेक्ट में डिफ्रेंशिएट कर रहे हैं. दैट्स वाई दिस इज द व्हाट, दिस इज द एंगुलर acceleration. This is what? Angular acceleration. Okay, and now going to put all these. So here tau I is what? Tau I means now it is 1 for the joint one, and d by dt of partial differentiation of L, and it is theta 1 theta dot. Second step is this one, del L divided by del theta 1, and putting all this, so what we get? So this one means m L square theta 1 double dot, and what is the value of the means what we got. So from here we can write here, see what is here. So this one, so here next is with minus sign, and in bracket you have to take, and what is the value of this means del L divided by del theta 1. This is what? So minus mgl 1 cos theta 1 minus mgl 1 cos theta 1, and it is equal to then m L square and theta here double dot, and 1 theta 1 will be here, and it becomes plus positive mgl1 cos theta 1. So this is tau 1, and this is the required equation. Either you can see the governing equation or the torque equation, which is responsible to give the moment to the manipulator. Responsible for this tau is responsible for the motion of the robot. Okay, so once again this the Lagrangian operation, so it was tau I, and it is d by dt and del L del and theta 1 dot here, and here theta sorry I minus del L then del theta I. Okay, so one thing need to remember, here is a differentiation of what? Of angular velocity. Here differentiation of what? Angular position. And L is what? L is the Lagrange operator, and that is equal to kinetic energy minus the potential energy. And what is tau I? So tau I is summation of all the torques generated at the joints. The summation of the torque generated or supplied at, or you can say to the joints. So with this, thank you.